2D collisions. Before I start, if you've not watched my video on 1D collisions, watch that before this one so you understand the content better. 2D collisions are very similar to 1D collisions because momentum is conserved. The only difference is that there is now an x and y axis. That being said, it is still the same formula. Momentum before equals momentum after. But now it is momentum in the x-axis before is equal to momentum in the x-axis after. So you have to separate the x and y-axis from each other. This formula goes for the y-axis as well. Just remember, always separate the two axes because they don't interfere with each other. Let's look at some examples. An 100-gram billiard ball going 6.5 meters a second east runs into another 100-gram billiard ball that's sitting at rest. The second billiards ball's velocity after the collision is 4.2 meters a second east, 25 degrees north. What is the first billiards ball velocity after the collision? All right, so I wrote down the problem right here. So I have a before and an after. So we can see before, the velocity of the first one is 6.5 meters a second in the east direction, which I made positive, so I just changed that to positive. Then it's going to hit the next one, which isn't moving at all, so it has velocity of 0 meters a second. This is after, so you can see that's velocity B right there. I drew it in red, so you can see it's the red one right there. And then of course theta B, and then we have A that's unknown. So we're trying to find A. So because conservation of momentum is separate in both the x and y axis, we can pick whichever one we want to do first. So I'm going to say we should do, let's do x first. So we're going to write in the first equation. So I'll skip ahead to what that will look like. So yeah, skip ahead. Okay, so total momentum in x at the start is equal to total momentum in x at the end. So before and after the collision. And then let's fill it in for what we know. All right, so I have the answer written in here. So not the answer, but I wrote down the equation. So also there's supposed to be a mass right there. So they're all multiplied by mass, which means we can take out all the masses, okay? And since because they all have the same mass, which is 0.1 kilograms, we can only take out the mass because they each all have the same mass. So we can divide by mass on everything, and then it will all be equal. And then another thing we can take out here, so velocity b of x is equal to 0, right? So we can also take out this one. That one's also equal to 0. So here, actually, I'll erase these guys out. So that's equal to 0. And then take out the mass. Take out the mass. And then this is what we're left with. So we'll fill in for what we know here. This is also prime. And then we'll fill in our number here to see what this looks like. So I'll skip ahead. Okay, this is what we're left with. So if you're confused about anything, so the 6.5 meters a second comes from up here. You can see equals to 6.5 meters a second. And the cos 25, so we can see using SOHCAHTOA rules, we're using, it's an x, right? So that's like this component right there. Here, I'll draw in another color. So it's going to be the green component, okay? In order to find the green component, we have to do cos 25 multiplied by the hypotenuse, right, which is 4.2. So that's how we get the velocity prime of b of x, right? So this is like the green arrow right there. That is the green arrow. Okay? And then we're eventually trying to find velocity of a of x. And the reason why we don't have a like an angle here is because we're going to try to find, so here I'll draw this in another color up here. So we're trying to find purple. So that's purple right there, which doesn't have an angle at this moment, right? So there is going to be an angle right there, which we eventually need to figure out. But if we find the x component, and then we also find the y component, so here I'll draw y as orange. If we find the y component as well, then we can use those two vectors to find the angle and to also find the hypotenuse. So we'll be able to find both the velocity, like the total velocity, and then also the angle based off just getting the magnitude. So just getting the magnitude in the x and the y. So I'm going to move this to the other side. It's going to subtract, so that's going to move to the other side, and then we're going to get an answer for VAX. So here I'll skip ahead to that. Okay, so this is our final velocity there. So I move that to the other side, and then you just put this into your calculator, and then you should get positive 2.69, blah, 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 blah. And you want to keep that many decimal points because when you eventually find the angle, you want it to be as accurate as possible. So you wouldn't want to round this to like 2.7, right? Like if that was your final answer, yeah, you'd round it to 2.7, but it's not your final answer yet. So you want to keep those numbers, keep as many of them as you can so you can find a more accurate answer. All right, so that's an x. That's total momentum in x. Let's do momentum in y now. So yeah, we're going to do same equation from up here, just now in y. So here, I'll skip ahead to that. Okay, so I wrote down the first equation and then I simplified it a little more, or I expanded it out a little more. So this is what it fully looks like. And just like before, we're going to take out the masses. So I'm going to erase all the masses. And then there is some other stuff we can do for this one as well. So VAY, if we look up at the top here, so there's no velocity in the y-axis for either A or B at the start. So we can actually erase both these. So both these are going to be erased, and you can just replace them with a 0, right? So this entire left side here is just going to be 0. Now there is a velocity for these two over here, right? Or at least we think there will be, and there has to be, right? Because these two, they basically have to equal each other. They have to be opposite, but they have to equal. So like we can move this one to the other side there, and then we'll see that they're equal, right? So VAY prime is going to equal sine 25 multiplied by 4.2, right? So here we'll move that one over, and then I'll fill that one in. So I'll skip ahead. Okay, so I just moved it to the other side there, and it's negative because I moved it to the other side. And then basically to solve the rest of this, you just do sine 25 times 4.2, put it in your calculator, and you'll get negative 1.7747996699. And that's meters a second. So again, we're going to keep all those decimal points to make it easier later on. And now we have two values here, right? So we have negative 1.777, which means that it's downwards, right? Which means it's south because it's in y, so it's south. And then we have positive 2.6935, which means it's east, which is positive, right? So let's draw what this looks like. So it's like this, and then it's a little bit down, but it's not as far down as it is to the right. And then, so I'm going to use different colors here. So I'll do purple, and then X is purple, okay? So that's purple. And then orange is this one right here. So yeah, sorry I'm explaining it so much, guys, but I'm just doing this for people that may not understand it. So the next one, I won't explain it as much. And then I'm going to draw blue as this guy. So that is the final, that's VA prime, okay? So, and then of course there's also theta. So there's a theta between here, which is just the direction of it. So in order to do this, we're going to have to use Pythagoras theorem, right? So we're going to do, here, I'll skip ahead and draw the equation in. Okay, and this will get the absolute value. So if we plug in, this will get the absolute value of the velocity. So it's kind of like the speed. It's not the actual velocity yet because velocity has to have a direction, but this will get the speed. So I'll skip ahead and fill this in. Okay, so I just filled in the numbers there. So that's that one, that's that one. And then I also have our final answer, but it needs a direction. So now we have to use SOHCAHTOA rules to basically find what theta is, right? So that's Vx, that's Vy. So let's do opposite over adjacent. So tan theta. Here, I'll skip ahead to show what this one looks like. All right, so there's this one filled in, and then we're just going to do inverse tan to find what the angle should be. Okay, so I filled in the numbers here, and then if you just put it into your calculator, so 1.77499 goes on for a few more decimal points, divided by 2.6935, a few more decimal points. Tan inverse that, you get 33 degrees, which means we can put these two things together now. So then VA prime is going to equal 3.23 meters a second, and then square bracket. So now it's going to be east first because, see, 33 degrees. So the smaller one is going to have to be Vy, right? So Vx is the biggest one, which means it's east first. So east 33 degrees, and then south. Let's look at another example. Car A with a mass of 1500 kilograms is going 20 meters a second northeast, and it runs into car B that is going 14 meters a second south 15 degrees west. It has a mass of 1800 kilograms. If car A is at rest after the collision, what is the velocity of car B after the collision? So I have a drawing here of what this will look like. So you can see this is car A at an angle of 45 degrees because it's northeast. And then this is car B, angle 15 degrees southwest. So we have the masses here as well. So 1500 kilograms, 1800 kilograms, the velocities, and then velocity at the end. So let's go straight into it. So first thing we're going to do, just like at the start last time, we'll do so in x first. So in x. Here, let me write that better. So in the x vector, let's do, so I'm just going to write down the formula. I'll skip ahead. Okay, so this is what it should look like. So momentum in x at the start equals momentum of x at the end. And then this is all the individual momentums in the system. So I'm going to fill in for all the variables here. And actually, before we do that, so remember, so A is going to finish at rest. So this one right here, we can just take right out. Or I'll just erase it because it's equal to 0. So that one doesn't need to be there. And then I'll fill in for the rest of them. So I'll skip right ahead to that. All right, so I have this thing all filled in here. So we have all the masses in, and then also, of course, the angles needed to then get the proper x vector that we need, or x-axis that we need. So we did cos 45 because cos is adjacent, and this is adjacent to the angle here. And I did sine 15 because it's the opposite, right? So that would be opposite of the angle from up here. So that's what we did, those two. And basically what you need to do now, so put these two numbers in your calculator, divide, and then subtract them. Oh, sorry, yeah, the reason why I did subtraction here as well, instead of addition from before, was because this component is going west, it's in the negative direction, so this just becomes negative. So yeah, you're going to put this whole thing into your calculator, get the answer, and then divide by 1800 kilograms, or 1800 kilograms, and then you'll get the velocity in the x-axis. So here, I'll skip ahead to that. Okay, so yeah, I put those two numbers in my calculator. Those should be the two numbers you get, so this one and that one, and then divide by 1800. So yeah, subtract the two, divide by 1800, and you should get this number right here. So that is the x velocity for B, but now we need to find the y velocity. So we're going to do the same sort of thing, but now in the y axis. So I'm going to skip ahead to show what that should look like. All right, so filled in the numbers here, and then I'm going to replace them with our actual values. And then, of course, remember at the top here, so velocity a prime equals 0. So I'm going to take out this term right there because it equals 0. And then I'll fill in the rest of my numbers. So I'm going to skip right ahead to what that should look like. Okay, so I filled in all the numbers here. So again, it's sine 45 because it's a 45-degree angle. And it's sine because we're doing y up here now. And then it's cos 15 because it is adjacent to the angle. So it's right up there, okay? So both on the y value, both on the y-axis. So we do the same thing that we did like up here. So we're just going to put these numbers into our calculator, divide by 1800, and then you should get your answer. So I'll skip ahead to that. Okay, so there we go. I filled it in, put it in my calculator. That's your final answer right here. So velocity in the y-axis for B is equal to negative 1.7378 meters a second. So now we have to use Pythagoras' theorem to find the magnitude of the velocity, and then after that we can use our trigonometry from before to find the direction of it. So I'll skip ahead to doing the magnitude. All right, so yeah, we do Pythagoras' theorem, so I just moved the square root over. So there used to be a square here, and then you move it over by square rooting. So then you get square root on this side, and then you just plug in your numbers, square them, add them together, and then square root it, and then you should get this number right here, so 8.34 meters a second. There's more decimal points, I just rounded it to that. And then let's find the direction now, okay? So I'll skip ahead to doing the direction. Okay, so this is what we have finally here. So we have the speed, and then we have the direction. So 12 degrees. So let's just put it all together now. So let's take a look at this. So we had x as 8, so it's going to be like x is like this, and then y is 1.7, so it's going to only be like that. And that is what the triangle kind of looks like. So that's 12 degrees. So we can see it's going east, and then it's going south. So based off that, we can say velocity b prime equals 8.34 meters a second, and the direction is east 12 degrees south. So east 12 degrees and then south. There we go. And that's our final answer for that one. So yeah, it's about same amount of work as last time. Anyways, I'll skip ahead to the last one here. Let's look at a completely inelastic collision example. A 10 kilogram box is pushed 5 meters a second on the floor into another box that is 5 kilograms going 8 meters a second perpendicular to it. What is the final velocity of both boxes? Okay, so I have a drawing right here. So before and after. So we have all the velocities and masses in here. I set up to positive, right is positive as well. And then because it's completely inelastic, they are joined together at the end, so they have the same final velocity. And then if their masses are together, so it's a mass of 15 kilograms. I'm going to skip the first step of drawing in like p tot x and p tot y. I'm just going to go right into the very first, or right into the very second line. So I'm going to skip ahead. All right, this is what it should look like here. So I'm just going to fill in all our numbers, and I'll skip ahead again. Okay, so I wrote in our numbers here, and then one thing we can do here, so velocity b of x is equal to 0, right? Because velocity b here, so it's perpendicular. So actually, I guess I kind of forgot to talk about this. So perpendicular means that it can come either from that one up there or from the one I set it to. So you can pick either one. I just decided to make it going up because I thought that'd be easier to do. So it's coming up, which is perpendicular. So therefore, there's no velocity in the x category. So this one right here, we can just take away completely. It's equal to 0. And then I'll fill in for all our numbers here, and then I'll solve. So I'll skip right ahead. Okay, so this is what I have right now, and then I'll just divide by 15 kilograms on both sides. So divide by 15 here, divide by 15 there. And then this should get you an answer of 3.33333. So let's write that in. So 3.333, and then goes on forever, equals VABX prime. Okay, and then it is positive, of course, because right is positive. So that is that. And then let's do in the y category now. So same thing as before. I'll skip right ahead to what it should look like. So I'll skip right ahead. All right, this is what it should look like here. And then what I'm going to do, I'm going to take away the a out of this because a has no y component. So this can get taken away because it equals 0. So that whole term will equal 0. And then this is what I'm left with. So I'll just fill in for my numbers and then solve. So I'll skip forward again. Okay, this is what I got here. So 8 meters a second times 5 kilograms equals 15 kilograms times the velocity of ABY. So you just divide by 15 kilograms on both sides here. This gets multiplied by 40, divide by 15, and you should get 2.66666. So 2.66, and then it goes on forever until it eventually hits 7. There we go. And this one's also, of course, positive. So then just like before, you're going to do the vector components, use Pythagorean's theorem to solve for the final velocity. So I'll skip ahead to that. There you go. So I put in the numbers in here. So 3.333 squared plus 2.6667 squared. I'll add those together, square root it, and then you should get 4.27 meters a second. So that's the magnitude of it. So let's find the direction. So we're going to use the tan function from before. So I'll skip ahead to that. All right. So here it is. So theta equals tan inverse of the opposite over adjacent. So this is opposite. There's adjacent there. I drew the triangle. And then you'll eventually find that theta equals 39 degrees. So you can put these two things together. So VAB prime equals 4.27 meters a second. And then the direction, so what do we have? So right, 39 degrees, and then down. Actually, no, sorry, it's not down, it's up. Yeah, right, it's up. Yeah, because that's positive. So sorry, it's not down, it's up. I drew the triangle upside down there, so right, 39 degrees up. There we go. That's all. That's all for this video. I know it was a long one, but yeah, it was still good though, so good work. Hopefully it all makes sense. If you have any questions, leave them in the comments, and then let me know what you would like to see next.